Hello everyone, I'm Nandini Dikhe and today I would like to discuss about the topic conversion of analog data to digital signal in the upcoming video. But before coming up to the main topic, I would like to give a basic introduction to digital and analog signals. A digital signal is a signal that represents data as a sequence of discrete values. At any given time, it can only take on one of a finite number of values, whereas an analog signal is a continuous signal in which one time varying quantity represents another time-based variable. Analog signal uses a continuous range of values that help you to represent information. On the other hand, digital signal uses discrete 0 and 1 to represent information. Now, we will see some following methods for conversion of analog to digital signals. These methods are pulse code modulation, delta modulation, and adaptive delta modulation. Now, we will go through these methods one by one. The first method is pulse code modulation. The most common technique to change an analog signal to digital data is called pulse code modulation. A PCM encoder has the following three processes, which are sampling, quantization, and encoding. The first step in PCM is sampling. It is a process of measuring the amplitude of a continuous time signal at discrete instants, converting the continuous signal into a discrete signal. The below graph shows the difference between a continuous time signal and sampled signal. After the first step of sampling, the second step is quantization. Sampling yields discrete form of continuous analog signal. Every discrete pattern shows the amplitude of analog signal at that instant. It is done between the maximum and minimum amplitude value. Thus, quantization is a process of assigning integral values in a specific range to the sampled instances. The last process is encoding. The digitization of analog signal is done by the encoder. After each sample is quantized and the number of bits per sample is decided, each sample can be changed to an n-bit code. Lastly, in encoding, approximated value is then converted into a binary form. The given graph shows an overall look to the complete process of pulse code modulation, which includes sampling, quantization, and encoding. Now, the second method for conversion is delta modulation. Since pulse code modulation is a very complex technique, other techniques have been developed to reduce the complexity of pulse code modulation. The simplest method is delta modulation. In it, the modulator is used at the sender side to create a stream of bits from an analog signal. The process records a small positive change called delta. If delta is positive, the process records a 1, else the process records a 0. The modulator builds a second signal that resembles a staircase. The input signal is then compared with the gradually made staircase signal. The given graph is an example of analog signal after delta modulation. The last method for conversion is adaptive delta modulation. The performance of a delta modulator can be improved significantly by making the step size of the modulator assume a time-varying form. A large step size is needed where the message has a steep slope of modulating signal, and a smaller step size is needed where the message has a small slope. The size is adapted according to the level of the input signal. This method is known as adaptive delta modulation. Thus, in this video, we learned about the process of conversion of analog data to digital signals. I hope this video helped you understand the topic. Thank you.